C3H8, also known as propane, is a covalent molecule and has a covalent bond. Covalent bonds form between nonmetal atoms and involve sharing a pair of electrons. In propane, there are 3 carbons, which have 4 valence electrons, and they have 8 hydrogens, which have 1 valence electron. If you multiply the amount of carbons with the valence electrons and the hydrogens with the 1 valence electron and add them together, they will have 20 valence electrons in the entire molecule. The Lewis dot structure will then bond the molecules together like this. The bonds linking each molecule to one another are known as chemical bonds, and they each have 2 valence electrons. If you notice, the hydrogen molecules each have 2 valence electrons for each hydrogen, which means that the outer shell is full. Each carbon has 4 single bonds and 8 valence electrons, which then completes octet's rule by having each carbon outer shell filled. PO4 to the -3 is also known as the phosphate ion, which is a polyatomic covalent ion. Polyatomic covalent ions are nonmetal molecules composed of 2 or more atoms bonded with a negative or positively charged atom. For the phosphate ion, phosphorus has 5 valence electrons and 0 non-bonding electrons. So you divide the electrons that are bonding by 2, which is +1. And then for oxygen, you have 6 valence electrons with 6 non-bonding electrons, which you divide the bonding electrons by 2, which gives you -1. The phosphate ion looks like this in the Lewis dot structure form. But as you can see, you still need the -3. To gain the -3, you will have to take out an unbonded pair from the outer shell of oxygen and place it with the phosphorus inner shell. As you can see, we took out an unbonding pair from the outer shell of oxygen and placed it in the inner shell of phosphorus, which will give you a double bond. Now that you have completed the Lewis dot structure and have created a double bond, you now need to place brackets around the entire formula to indicate that you have taken -3 atoms from the outer space.